Myself, Dr. Babu, working as an assistant professor in the Department of Electrical and Electronics Engineering, Aditya University-Surampalem. We are going to discuss about introduction of two-port networks. At the end of this session, students are able to understand the elements of two-port network. First, what is meant by a two-port network? So, if you observe the circuit diagram, there is a system called network in which two ports such as input port and output port were given, where input port is connected or known as driving source and output port is connected to load. Okay, so if you observe the input port means the terminals of input port are 1 dash and output port are 2 and 2 dash, and where I1 is the current flowing through the input port and V1 is the voltage across the input port, and I2 is the current flowing towards the load, and V2 is the output voltage flowing to the passing through the load. So if you observe, this means what is a network? From the circuit diagram or generally you can observe that a network is a combination of resistance, inductance and capacitance where the passage or flow of current will be existing. Okay. So coming to the convention, in two-port networks we will be going to use the voltage convention or current convention. So come to the introduction of two-port networks. As I have stated earlier, a network consists of two pairs of terminals which is called as two-port network. Two pairs of terminals, that means input pair and output pair. Okay, and in general it is designated as 1 dash as the input port or driving energy source port, or 2 dash connected to the load or output port. In some of the textbooks it will be called as AA dash and BB dash also. And for these two-port networks there are some assumptions saying that these voltages and currents inside the box are not available for the measurements, because here see, if you observe, this means here voltage and currents are there and here we are measuring voltage and currents, but inside the box we will be not measuring these things. And the network consists of only linear elements, that means only resistor kind of thing with dependent sources, not resistance and capacitance. And also the initial conditions on the capacitor and inductance on the network is assumed to be 0. Okay, that means the initial conditions, previously we have discussed that the initial condition on the capacitor is V of voltage across the capacitance, Vc of 0 plus is equal to Vc of 0 minus is equal to 0. Like that, even for the inductor also, the network capacitance is 0. And the final one is the voltage and current at the input and output terminals are V1 and I1 and V2 I2 respectively. Okay. First, what is meant by network? As I have stated earlier, a network is the combination of the passive elements RLC and they are connected by the external connections with active sources, that is voltage and I. Here we are going to use the voltage and current convention, that is the direction of both the currents I1 and I2 are flowing into the network. That means the I1 current is also flowing through the network and I2 current is also flowing through the network. And also the voltages and currents require a linear equations. Okay, and here in the circuit if you observe, this means, okay, here there are generally 6 different pairs of networks are there: Z port, Y port, T port and T inverse, H and G. Okay, now we will be going to look into one by one in detail. So if you observe this network equations of impedance parameters, this is also known as Z port parameters. So in impedance parameters, V1 is given by, here 1 means input port and 2 means output port. So V1 in the sense voltage across the input terminals, V1 is equal to Z11 I1 plus Z12 I2, where Z11 is the Z11 and Z12 are the impedances, whereas V2, that is voltage across the output port, is given by Z21 I1 plus Z22 I2. Okay, here I1 and I2 are the input and output currents and V1 and V2 are the input and output voltage. So if you observe this part, this Z11 and Z22 are self impedances, and whereas Z12 and Z212 are mutual impedances. Coming to the second type of parameters, that is admittance parameters, it is also known as Y port parameters. In Y port parameters, it starts with input current and output current. Okay, whereas the impedance parameters, it starts with input voltage and output voltage. So if you observe, this impedance admittance network is I1 is equal to Y11 V1 plus Y12 V2 and I2 is equal to Y21 V1 plus Y22 V2, where I1 and I2 are the input and output currents and V1 and V2 are the input and output voltages. In a similar manner, Y is admittances and Y11 and Y22 are self admittances, Y12 and Y22 are mutual admittances. Now coming to the third type of parameters, that is ABCD parameters or transmission line parameters. So in transmission line parameters, the input parameters will be input voltage and input current. Okay, and the input voltage and input current are given related with output voltage and output current. So if you observe this input voltage current V1 is equal to AV2 minus BI2. Okay, whereas I1 equal to CV2 minus DI2. V1 and I1 are the input and output voltages. V2 and I2 are the output voltage and output current. Where this A and B are, A is voltage and B is current, and where B is voltage by current, that is impedances, and C is I by V, that is admittances. Okay. While going through each and every circuit, we will be discussing about the impedances, units, and all the things. Now coming to the fourth type of network, that is inverse transmission line parameters. This will be inverse of the transmission line parameter. So if you observe this one for transmission line means V1, I1 are the input and output voltages, and it starts with V1, I1. Whereas in inverse transmission it will be V2 and I2. So if you observe the circuit, V2 is small b11 V1 minus small b12 I1, and I2 is small b2 V1 minus b22 I1, where b11, b12, b21 and b22 are inverse transmission line parameters, and b11 is in the form of voltages, and b12 is in the form of voltage by current, that is impedances, and b21 is current by voltage, that is admittances, and b22 is a current term. Next, coming to fifth type of network, that is hybrid parameters. So in hybrid parameters, the equation starts with input voltage and output current. So therefore the equation should begin with V1. V1 is equal to H11 I1 plus H12 V2, and whereas I2 equal to H21 I1 plus H22 V2. Here this H11, H12, H21 and H22, these are called as hybrid port parameters, and H11 is given by V1 by I1 in the form of impedances, H12 is V1 by V2, is in the form of volts, H21 is I2 by I1, it will be in the form of currents, and H22 is equal to I2 by V2, it is in the form of admittances. Okay. Now the final one is inverse hybrid parameters. So in inverse hybrid parameters, it is in the form of inverse transmission line parameters, that means opposite of ABCD. So inverse means hybrid means it is the opposite of hybrid, therefore it is V1 means it is V2, and I2 means I1. Therefore it starts with I1. I1 is given by G11 V1 plus G12 I2, and V2 is given by G21 V1 plus G22 V2, where G11, G12, G21 and G22 are inverse hybrid parameters, and G11 is I1 by V1, that is admittance, and G12 is I1 by I2 current, G21 is V2 by V1 voltage, and G22 is V2 by I2, which is nothing but admittance. Okay. So if you look into your problem means, we will be getting a clear idea about this part. Now coming to the properties of two-port networks. For any network to be a reciprocity or symmetric network, for reciprocity, the mutual impedance should be equal. Mutual impedances or mutual impedance should be equal. And for a symmetric, the self-admittance should be same. Okay, that means self means Z11, Z22, whereas reciprocity means Z12 and Z21. Those admittance should be same for reciprocity and symmetrical networks. Now coming to the application part, the two-port networks are mainly used for small signal transition modeling. So in small signal transition modeling, we will be having a series transistor where emitter, base, collector will be there. Input current and output voltage and input voltage and output current, the things will be there. And during that modeling part, during the small signal transient analysis, this two-port network will be useful. And next one is radio frequency and communication circuits, and in this also it will be very helpful. The third one is transmission lines and filters. So here you can observe this also, in that one of the parameter called transmission line parameters, we will be using this kind of two-port networks. Next one is power system analysis. In order to determine the efficiency or a regulation of a transmission line, we will be using these two-port networks. Okay. And coming to the summary, in this session we have gone through what is a port and what is a network, and how many ports are there for a two-port network kind of thing we have discussed, and also where the applications of these two-port networks are being used, such as amplifiers, filters, common electric circuits, common base circuits, those things we have discussed about these things. And also the various parameters such as impedance parameter Z, admittance parameter Y, transmission line parameters ABCD, inverse transmission line parameters, and also hybrid parameters and inverse hybrid parameters. All the 6 kinds of parameters and respective equations we have discussed. And also These networks can be connected in cascade kind of concept, either in series or parallel series or series parallel, that we will be going discussion further. And that these two-port networks are mainly used for analyzing the linear circuits and also useful for determining the performance and understanding of the signal transmissions. Okay, thank you.